Okay, so 5-3 exponential growth and decay. This one will require you to follow third formula, whether your equation is going up, exponential growth, or down by exponential decay. And then I don't think we'll get to the word problems. Yeah, the third one, you're not have to worry about it. You'll learn it in math too, so I'm not really that worried about it. But regards to compound interest, so really the only ones you need to focus on are exponential growth and exponential decay. So for number one, the number of students enrolled at a college is 18,000 and grows 6% each year. Complete parts A through E. So for part one, it says the initial amount is, it means how many you started with, in which this case we started with 18,000, nope, started with 18,000 students. Yes, but we're going from the very beginning again. The percent rate of change is 6%. So the growth factor of B is 1 plus 6% converted to a decimal. So since I taught you guys on Tuesday, how do I convert 6% to a decimal? Very good. Divided by 100. This gives me 0.06. So that means to find my factor rate, I take my percentage written as a decimal and I add it to 1. So 1 plus 1 plus 0.6 is 1.06 when you add them together. So those are the two squares. Unfortunately, the squares are really small, so I can't really fit the number in, but just adding them together. For C, to find the number of students enrolled after 1 year, you will calculate 18,000 times 1.06 because that is 1 year. So 1 year represents just 1.06, the factor growth. To find the equation, so to complete the equation, y equals blank times blank to the power of blank. Find the number of students enrolled after X years. So that means in order for you to write the equation, it's going to be 18,000, what you started with. Your growth factor, 1.06 to the power of a variable. In this case, the variable is X. X represents the number of years. So it'll just be 18,000 parentheses 1.06, whatever, how many years you're trying to find. So use your equation to predict the number of students enrolled after 26 years. So for part E, how many students would there be after 26 years? I will take my equation times my factor growth times the exponent to the power of 26. So this is going to require you to just plug it into your calculator. Be very careful. Do not do times 26. It's going to be to the power of 26. So to do that one, so 18,000 parentheses 1.06 parentheses, and then to the power, you have to use this little caret, 26. So there's 81,888.89 students at the end of 26 years. So make sure you guys plug it in correctly, because if you don't, it's going to get the answer wrong. So y is equal to 81,888.89. Now here's the thing, you have to make sure you read what it wants you to. It says round to the nearest whole number. So the nearest whole number is 81,889. This is the correct answer. If you do not round it, it's going to tell you it's wrong. You have to round. So when you start with 18,000, after a factor growth of 1.06, after 26 years, you should expect there to be roughly 81,889 students at that college. Does anyone have any questions? So pretty good. These are the exponential formulas. They're very powerful because they're able to determine prediction values. So it's pretty neat. So we're going to do it one more time. So number 2 says the number of students enrolled at a college is 16,000 and grows 6% each year. Complete parts A through E. So it's the same thing. I didn't get a chance to copy and paste all the different parts. In this case, we'll just go through one by one. So our first for part A, it asked us to find the initial amount, which in this case, it was 16,000. For B, it says find the percent rate of change 6%. So the factor growth is 1 plus blank. In this case, our percentage written as a decimal, which in this case is 0.06, right? Because it's the same as the previous one. So it's just 0.06. And then the total of the factor growth is 1.06. For part C, it wants us to know what number we would have to multiply after 1 year. So in this case, it would be 16,000 times our factor growth, which is 1.06. So after 1 year, if I want to figure out what it would be after 1 year, I just have to do 16,000 times 1.06. For part D, it wants us to know what the equation will look like with x representing the number of years. So the equation would be 16,000 times 1.06 to the power of x. The door should be open. So for part E, it says it's the same as the previous one. It wants you to know how many students will there be after 26 years. So for part E, it's asking you for the number of students. "26 years. And to determine that, I just plug it into my equation. 16,000 parentheses 1.06 to the power of 26. So if we do it by the calculator, we'll just do 16,000 times 1.06. If you want, you could put that in parentheses too. So 16,000 times parentheses 1.06 parentheses and then to the power. So you gotta put the root 26. So it'll be roughly 72,790.12, but when you round it, it's just 72,000. So this is 72,790.13, but when you round it, 72,790. Since 0.1 is less than 5, you round down, or not round down, you just keep it with whatever numbers on the left-hand side. So just 72,790. The reason why we round it is because we can't say 0.13 of a percent. That doesn't exist. So we always round it to the nearest whole number. So 0.13 of a percent doesn't exist. All right, any questions? Pretty easy, nothing too hard, just formulas. For number 3, says a pair of athletic shoes costs $85. If the inflation rate remains constant at 3%, write an algebraic rule to determine the cost of CT of the shoes after T years. So inflation. So when you hear inflation, do you think stuff costs more or costs less? More, right? So that means this is going to be exponential growth. Meaning your factor growth, your factor rate is going to be 1 plus the rate, which is the percentage, by the way. So this is growth. So you got to be careful though, because you got to make sure you listen to or you read the key words in the sentence, because they'll tell you whether you're adding or subtracting. So for this one, you are adding. So if I wanted to write a formula, CT, what number, what's my starting? What do I start with? 85. So that goes first. parentheses. And then I got to figure out what my factor rate is. So in this case, it's going to be 1 plus my rate, which in this case, what's my rate? You're close. 0.03. Remember, the rate has to be in decimal, not percentage. And then it's going to be to the power of t because it says that t represents the number of years. So instead of x, it's going to be t. Now, all it wants is the formula. It doesn't want you to determine how much it is after a certain amount of years. So in this case, it's 85, parentheses, 1.03 to the power of t. And that's it. That's all you're doing. All it wants is the formula. It doesn't want you to solve for anything. I probably should have done this first. So the formula for exponential growth is y is equal to, let me look at the notes for this. It's in the very beginning. Y is equal to a times b times x. A times b to the power of x. Now a represents your starting. And then b represents your factor growth, factor rate. So it's either 1 plus the rate or 1 minus the rate. And then R means your rate, your percentage in decimal form. And then 1 plus R is growth. And then 1 minus R is decay, meaning it's getting smaller. So please make sure you have those in your notes because it is very, very important. Okay, let's move on to the next one. For number 4, there's 2 parts. It says, at the end of the advertising campaign, weekly sales amounted to $2,000 and then decreased by 1% each week after the end of the campaign.
It says 20,000.
My apologies. $20,000. Write an equation of the exponential function in the form of p minus p naught parentheses 1 minus r to the power of t. That models the weekly cell. So this is honestly the same thing we did. Y is equal to a times b times x. It's honestly the same thing. The only thing is I already tell you that this is a decay. This is getting smaller. So that's why it's y1 minus r. So if I try to plug it in myself, what do I start with? 20,000. Why do I keep saying 2,000? 20,000, right? So then what is my rate? What's my B? What? You're very close. You're very close. How do I find my B? 1. Okay, so yes, but so it's not 0.01. It's 1 minus 0.01. Remember, you have to find the factor rate. So you have to take 1 minus your rate, which is in percentage. So what's 1 minus 0.01? 0.99. That is your B. So you have to be very, very careful. Your B determines whether you're increasing or decreasing. Since it's decreasing, and it even tells you it's decreasing, it literally says right there, decrease. You're gonna have to do 1 minus the rate. So 1 minus 0.01. And then this would be X. Or in this case, it's going to be T because it wants it as T. Does anyone have any questions so far? Because when you try to solve for it, what's the answer? A, B, or C? Is C. It is not A, do not make the mistake 20,000 parentheses 1.01 because it's not correct. Does that make sense? Do you guys have any questions? Because this is decay, it's decreasing. Okay. And then for B, it says find the sale 6 weeks after the end of the advertising campaign. So when you do this, you plug it in, 20,000. 0.99 to the power of 6, because we want to know what it is after 6 weeks. So if we do this on the calculator, 20,000 parentheses 0.999 parentheses to the power of 6. We get 18,829.60. Since this is money, you can just round it to the nearest tenth. It says do not round until the final answer and then round to the nearest dollar. So this one does want you to round. So 18,829.60. Now, since it wants you to round to the nearest dollar, we're gonna round up because it's 60. So this would be 18,830. Very good. 30.00. Actually, you don't need the 00. It just wants you to round it to the nearest dollar. Does anyone have any questions? Now, since you're decreasing, right? So the number that you found, would that be smaller or bigger than the number you started with? Smaller, right? So you know if you did it right or wrong by looking at the number. If I know for a fact I'm getting smaller, this number has to be smaller than the number I started with, right? So that's one way you can double check your work to make sure you're actually doing it correctly by knowing whether it's increasing or decreasing. And in this case, we know it's decreasing because it literally says it's decreasing. All right, does anyone have any questions? Does everyone understand how I got 0.999? Because that's the important part. 0.99, because it's 1 minus the rate, so 1.01. All right, for number 5, assuming the exponential function has a starting value of 18 and a decay rate of 47%, write an equation to model the situation. Okay, so y is equal to a times b to the power of x. What is my a? Okay, good. How do I find my b? Very good. It is decay, so that means I'm going to take 1 minus my rate. 1 minus 0.47. I need to move this. Okay, so my B is in fact 0.53, 0.53. So when I put it all together, my equation is 18 times 0.53 to the power of x. And that would be my answer. Yes, Leo. Oh, this one? Yeah, it's the same thing. Yeah, it's the same thing. Whether you put the times or not, it doesn't really matter because they means the same thing. So if you want, you don't necessarily need to have the multiplication. Oops, too big. But you can if you want to. All right, last one, and then we're done. See, pretty easy. So for number 6, assuming the exponential function has a starting value of 360 and a decay rate of 72%, write an equation to model the situation. So y equals a times b to the power of x. What's my starting value? What is my b? 1 minus 0.72. So 72% as a decimal is 0.72. So when I subtract that, very good. 0.20 or 0.28. It actually, yeah, you don't have to have the 0, but you gotta have the point though. So to write the equation, y is equal to my starting value, 360, parentheses, 0.28 to the power of x. And that is my answer. And that's it. Pretty easy, not gonna do a lot. Just make sure you understand how to solve for b. I would say that's probably the hardest thing, whether you're doing 1 plus the rate or 1 minus the rate to get to b. Other than that, that's honestly the end of the lesson. We finished really early today.